Stephen Hawking made a bold prediction in 1971. The surface area of a black hole can never shrink. Now, more than 50 years later, we finally have the clearest proof yet. Thanks to LIGO's most precise detection of a black hole merger, scientists have confirmed Hawking's area theorem with incredible detail. Today, we'll break down what happened, why it matters, and how it could reshape our understanding of space and time. In 1971, Stephen Hawking proposed what's now called the area theorem. The event horizon of a black hole, essentially its surface, can only grow or remain the same, never shrink. Think of it like entropy in thermodynamics. Disorder always increases. Similarly, black holes always grow in surface area, especially when they merge. But for decades, this was only theory. No one had observational proof, until now. In January 2025, LIGO detected a powerful gravitational wave signal called GW250114. It was strikingly similar to the very first detection back in 2015. Two black holes, each about 30 times the mass of our Sun, spiraling together and colliding. But LIGO is now almost 4 times more sensitive than a decade ago. That boost gave us the sharpest signal yet, letting scientists peel apart the frequencies, like isolating instruments in a symphony, to study the fine details of the merger. LIGO works by firing lasers down 2 long tunnels and measuring tiny distortions in spacetime as gravitational waves pass. We're talking changes smaller than a proton's width. When 2 black holes merge, they send out ripples across the universe, and LIGO turns those ripples into sound. That's how we can hear the ringdown, the cosmic reverberation as the new black hole settles into its final form. This ringdown is key to testing Hawking's ideas. In GW250114, scientists measured the black hole's ringdown with unprecedented clarity. They found the 2 original black holes had a combined surface area of about 240,000 square kilometers, the size of the UK. After merging, the new black hole's surface area was around 400,000 square kilometers, about the size of Sweden. Bigger, just as Hawking predicted. This is the most direct observational evidence yet that black hole surfaces really do obey the area theorem. This discovery also backs another big idea, the no-hair theorem. It says black holes are simple creatures. All you need to describe them is mass, spin, and charge. Nothing else matters. By analyzing the overtones, the faint higher-pitched notes in the gravitational waves, scientists confirmed that the final black hole's properties matched theory perfectly. It's more evidence that general relativity still rules, even in the most extreme environments in the universe. Why does this matter? Because black holes connect the biggest mysteries in physics. Hawking showed that surface area behaves like entropy, a measure of disorder, linking black holes to the laws of thermodynamics. That means black holes aren't just cosmic monsters, they're laboratories for the nature of space, time, and even quantum gravity. Each merger we detect is like a new experiment on the edge of physics. Kip Thorne, one of LIGO's founders and a close friend of Stephen Hawking, recalled that when the first gravitational waves were detected in 2015, Hawking immediately asked, "Can this test my theorem?" Hawking passed away in 2018, but if he were alive today, he'd be thrilled. His idea, once thought impossible to test, has now been confirmed by the universe itself. So what have we learned? That Stephen Hawking's area theorem still stands strong, that black holes grow when they collide, and that humanity now has the tools to listen to the deepest truths of the cosmos. What do you think this means for the future of physics? Could black holes help us finally unite quantum mechanics and general relativity? Let us know in the comments. And don't forget to like, subscribe, and share for more deep dives into the universe's greatest mysteries.